Hi, welcome to my channel. I thought I would do a fun project, so using evolutionary algorithms, I trained a group of critters to reach a certain tile and then pitted them against each other to reach a certain goal on a two-dimensional grid. The program may sound simple, and it is, but it demonstrates the power of evolutionary algorithms to find solutions in a particular search space without having to wade through advanced math. So here's an overview of the project. As I've just mentioned, the goal of this project is to train a group of critters to reach a particular location on a map. There are two parts to this. First, the critter must find their way to the portal, and second, they must find their way to the portal in a minimum number of steps. This is not a difficult program to code. I will step through all the significant bits and walk you through setting up the directory structure. Here is the program. I finished it, and this is the final version running. What you see here is the very beginning of the program. The critters they've been assigned random paths. Selection hasn't worked on them yet, but I just thought I'd give you an idea for what it's going to look like in the end. I'll just say a few things about the program right now. First, as you can see, I didn't spend time making the movement of the critters smooth or creating sprites. I'll leave that for you. But if you do want me to do a tutorial on that, how you might do that, leave a comment. As you can see, I used a constants file to keep all the important variables in one location. This makes it easy to see what values you're using for the various parts of your program and to change them. I'm also happy to be able to say that I've tested the program and it does work. After I finished, I ran a series of tests to see if the algorithms worked and were actually teaching the critters. I kept the testing simple and ran the critters through a series of learning runs and then compared their progress to a series of random runs to see if they learned faster when I applied the algorithms. And they did. When I applied the learning algorithms, the critters found their way to the goal after an average of 21 steps. But when I randomly generated paths for them, they reached their goal after an average of 53 steps. And one critter just wandered aimlessly, never finishing. So that's not really rigorous statistically, but I think it gives a pretty good idea that it worked, that the critters were learning. Okay, so about the algorithms, I'll step through that code later, not in this video tutorial, but in a future one. But I'll just say here that I used 3 procedures to train the critters, which correspond roughly to selection, mutation, and crossover. I want to stress that, at least in my opinion, there's no one way of doing this. If the algorithms doing code work, they work. During the selection process, I took the most successful paths and preferentially inserted them into the next population and then randomly mutated certain sections of the critters, what I'm calling their DNA. For crossover, I drew random pairs of critters from the population and swapped their genes. So let's talk a little bit about preparation. For instance, assets. We'll need a few assets to start this off. Here is a shot of the images directory. I didn't use all of these tiles. I included them just in case you want to play with making your own custom environments. By the way, you can download everything I've used to create this program, all the tiles, all the program files on my GitHub repo. The link is in the description below. I wanted to avoid copyright issues, so, as you can tell, I made all the images myself. Please feel free to use them, alter them, give them away, do whatever you like. You can easily swap any of the tiles out and use your own better looking assets. I anticipate that there's going to be 3 videos in this series. I've already finished the program, I just have to write the scripts for the videos. In the first video, this one, I will step through setting up the directory structure, the map, and the environment files, as well as the graphics. When you complete the project for this video and press run, you will see your environment spring to life. In the next video, I will add our critters and get them up and moving through the landscape. Also, we will set up the main program structure and make it capable of producing generations of critters. After we've got all that set up, in the third part, we will finally implement the evolutionary algorithms. I'll also finish the series with some suggestions for how you can extend the program. For example, you can tinker with the contents that control certain environmental variables. You can also fiddle with things like mutation rates. Also, when you see what I've done and how I've done it, it will be easy for you to implement your own algorithms. You can then test them and see what effect they have on the critter's learning rate. But I'm getting ahead of myself. This is part 1, so let's set up the environment. So now we're at setting up the program. First though, let's take a 10,000 foot overview of the program. I'll just sweep through it so we have an idea of where we're headed. This is the directory structure. Here's an image of it. I keep the map and environment files in the data directory. As you can see, the data directory has two subdirectories, images and populations. The population files are either a beginning file or a values file. I'll talk about all this in more detail later. The general idea is that we randomly generate the values for the first population, and these values are put in the pop00.txt file. This file is read, and we put the critters through their paces by setting them loose on the environment and seeing how they do. Then we save the data to the values file. After that, the program looks at the results, puts the critters through selection, mutation, and crossover, and then saves the result to a beginning file. I call the beginning files the files that are pop and then a number and then .text, and the value files are the ones with pop and some number / and then the word values and then .text. And the values file, as the name indicates, actually hold the values that they scored given their movements during their turn. Anyway, that's the basic idea. So now let's start setting up the environment, and we're going to do this in stages. I always start my program in main.py. For this program, it's going to be very, very simple since we are just setting up the background. All we need to do is initialize the game class and then call the main function. Of course, in order to initialize the game class, we'll have to initialize the graphics class as well. That might sound like a lot of work, but it isn't. And once we've set up our graphics classes, we can safely ignore them since they won't change. Before we look at the game class, let's take a peek at the file where we keep our constants. I won't be using all the constants in this file. I included the colors, the color values, just in case someone would find them useful, but I'll use the rest, specifically the tile and zone names. Not maybe in this particular program, but in the ones to come. Now let's take a look at the game class. As you can see, we are creating an object variable from the game class. Then we use that object variable to access the attributes and methods of that class. The first thing I do is check to make sure the zone the program is being asked to load is in the list of zone names that I just showed you, the one in the constants.py file. You don't have to do this, but I thought it would be nice to have a list of environments in one place. After we initialize Pygame, we initialize the clock. About the clock, clock tick 10 means that, at most, 10 frames will be displayed in a second, 10 or fewer. It's a way of slowing things down. Okay, back to initializing the game class. Next we set the title, you don't have to. The next line is very important because it gives us the surface we will draw everything on. The line after that initializes the font. Again, you don't need to do this, but it will come in handy in the next iteration of this program. Okay, now let's talk about setting up the graphics class. First, notice that we're initializing another class here. This class will draw all the background files. I'll come back to it in a moment. By the way, when you debug, you might want to set the background to something like bright pink, so it makes it easier to see if a tile isn't displaying. So that's it for initializing the game class. Since we've already gone over most of this, let's go right to the line self_inner equals self_breed_tiles. As you can see, all the environment zones are given the same name as the text file that contains the relevant data for that zone. I'll talk about the data files in a moment. So now we're in the function readTilesSelf. Reading in the environment file is straightforward. We read the environment file and put all the data in a dictionary object. There's really only one line we need to go over, and that's the line that gives us a new tile object from the graphics class. As you can see, we hand the dictionary object over to the background tile class and set those attributes. Also, we use the file name to load the image into memory and store it in self_image. Then I make sure it's the right size by transforming it. That's it for the background tile class, so let's move on. Let's now talk about the map and environment files. Here's what an environment file looks like. Obviously, the X and Y lines are coordinates. The kind field isn't used in this version of the program, but it will be in the next. If something is a wall, then the program will not move the critter into that tile, otherwise it will. We'll go over that code in the next video. The value field is essential. We won't be using it in this program, but when we implement our evolutionary algorithms, everything will depend on it. The file name field simply tells the program which tile it should grab in the images directory. Now let's talk about the map file. Briefly, I use a map file because it's a good way of specifying the environment quickly. Also, it's a good reference. Finally, it's a lot quicker to make a map text file and then write a small program to turn that file into an environment file than going through and typing out the environment file from scratch. I've written a small program, it's called generate environment from map.py, that does this conversion. I'm not going to be stepping through it, but you're welcome to use it to generate your own environment files. Now let's look at the main body of the program. This is the main function of the game class, and it drives the entire program. This is the game loop. While self keep looping is true, the loop will continue. As soon as it is set to false, the program will quit. So let's take a look at the events function. In the first line, we get an event from Pygame. Right now, we're just interested in using this loop to close the window and stop the program. I've left the return event and the user has pressed the A key event as an illustration of what you can do, although we won't be using either in this series. By the way, although we're not using the update function in this version of the program, we will be using it soon, so I included it as a shell. Now let's look at the draw function. The first line fills the surface with the background color. Then we draw the background tiles. As you can see, the part of this that does the work is the screen blit function. That's all pretty straightforward. But if the display isn't updated, nothing will be drawn to the screen. So we have this line as the last line of the draw function in class game. Pygame display update. Okay, that's it. I started to write out the script for the next video, so that will be up soon. I'm hoping within the week. Thank you for listening. And if you like my content, please do like and subscribe. Please do give me feedback in the comments. Cheers.